Okay, thanks for your listening to my presentation. My FYP project is retrieval of movie shorts, context learning from person recognition under constrained environment. Actually, nowadays the face recognition have achieved a great access using deep learning technology. There have been various mature applications widely used in normal life, but recognizing person under unconstrained environment still be an open challenge. Issues like unfavorable lighting, object occlusions, non-frontal faces, or even covered faces can significantly affect the recognizing accuracy. In this project, we aim to move beyond the existing works and present a framework to address the issues by exploring the context, which is the informal clues we could extract from the images. Let me give you some example first. Actually, in Figure 1a, you could see that some part of the instance are missing. For example, the first page, the lower body is missing. The second page, the face is missing. The previous work that is Metonite have shown that the problem, like Figure 1, could be effectively addressed by the region-based learning network. But the tricky thing is like in Figure 2a, we could see that obviously the first image is more respective than when we recognize Leonard. It is not fair to treat them as the same weight where we are learning. Here, the instance-dependent weight will help. This weight is learning with the region feature vector at the same time, which describe how outstanding this region represents this identity. The weight depends on not only the image clearness, this is very common sense, but also the virtual context. What is virtual context? It is when you recognize people at the most time. Face will be the most specific characteristic region, but when we cover the face, regardless the face, we still get some clues from the image, like the clothing when you dressed up in a suit is more outstanding than pure color t-shirt, or will if you don't wear anything, because when we take all of us when we take off the clothes, the body looks like very similar. But when you dressed up, some characteristic features like flowers or the domination you dressed up is another information clues you can extract from the image. This weight is well aligned across images, and in the framework we would like to propose one region attention network to combine these two methods, both feature vector extraction and also the weight learning. In this, besides the virtual context, we could also extract some social context. Actually, the social context is actually in this semester I didn't focus on the social context. So because of the time limitation, here is just very brief introduction. Here is another example. In Figure 2, it is different to recognize the bridge only from her back view, but her husband could identify it by its virtual context. Using the social relation of this couple, we could easily get the bridge identity by his husband's identity. It is similar when the twins situation, because in the previous work, it is impossible to recognize twins with the others, but now we could use this social context learning network to identify the twins with the help of their girlfriends or boyfriends. And also not only the person-to-person relation like this, we could also extract the information context from science to person relation. We call event here, like the wedding arc with the wedding couples definitely have some relation. Here, let's back to the virtual context matching. Uh, as mentioned before, the region attention network incorporates both region feature vector and the instance-dependent weight. The whole network could regard as two stages. First is the feature extraction, and second is the classification. The feature extraction will, in the feature extraction, the instance image will separate into four different regions: face, head, upper body, and the whole body. All of this region will feed into a convolution neural network to get its feature, and then send it to a fully connected layer to get the feature vector. And also this result also could send into a weight learn network, which is also a convolution network, which contains a convolution neural network layer and a fully connected layer and a sigmoid layer. The feature vector is each regional feature vector is a 246-dimensional vector, and his corresponding weight is a positive coefficient. After all of them have been perfectly trained, the result will feed into the classifier so that the framework could identify the instance class. Then we come to the experiment part. The experiment dataset totally contains 18,900 instances, and all of them belongs to 332 identities. This instance will separately half and half roughly into train subset and test subset. In the baseline model, actually, it contains the feature extraction network and the nearest neighbor classifier. What is nearest neighbor classifier? Because just an example in 2D dimension, if you want to identify some instance class, like in this case, you could find his nearest neighbor, because normally the more closer the instance is more similar. So it is high possibility that the green circle could be the same class as the right rectangular. But because of the system risk, which could not ignore, actually, in the real case, this model could not perform very good. So instead of this baseline model, I propose another KNN model, like it is the k-nearest neighborhood classifier. Also back to this example, when k equals to 3, then we choose 3 nearest neighbor of the green circle, which contains 1 blue rectangular and 2 right triangle. So obviously, when k equals to 3, the green circle will be assigned to the right triangle class. But when k increase, like k equals to 5, it will contain another 2 blue rectangular, 2 right triangle, and 1 right triangle class. So obviously, when k equals to 3, the green circle will be assigned to the right triangle class. But when k increase, like k equals to 5, it will contain another 2 blue rectangular, 2 right triangle, and 1 blue rectangular So actually the real green circle should be the blue rectangular in k equals to 5. The KNN model actually aimed to reduce the incidental area caused by the system risk, and this have already been proved by the previous work. But the tricky thing is, like, when we check the accuracy of the test site, the baseline model and KNN model didn't have any significant improvement. Actually, if you analyze this later, let's focus on the experiment now. After that, the two neural network model is proposed. Of them is using a fully connected layer and use dropout layer to reduce the overfit to reduce the speed of convert. And the NP-ReLU model have the best performance. It could achieve about 6.4% better than the baseline model, and also it could use the latest resources to achieve the best performance. The resource here is actually described when only one single GPU or CPU is involved in the experiment. How long it will take to achieve its best performance? You could see that the NP-ReLU model could achieve the best at both accuracy and the resource cost. Okay, and why the baseline model, why the KNN model didn't achieve much more better than the baseline model? Actually, one tricky thing is that, as we mentioned before, KNN should reduce identical error so that the accuracy could increase when k become large enough. But the fact is that, but the fact, you can see this. The fact is not as expected. Here are two conjectures. One is like the feature extraction stage is perfectly trained here, as ideally the same identity instance should get close as much as possible with the others, which is the same identity of this instance, and also the other identity instance should get as far as much possible from this instance. So in this case, Kn would not increase anymore because all the neighbors around it will be the same identity. But this might be possible because normally when we train the network, it is impossible to train them to the ideal cases. So most likely it is the second assumption. The feature extraction stage still not need to adjust, and as the feature vector is 256 plus multiple 4, it is actually a 1000 dimensional vector, which represents a huge field space, but there are only 332 identities needed to represent. So each identity maps a large subspace as well. Even in principle, KNN could reduce the identical error, but as the dataset is not big enough, this impact is not obviously. It could not cover the gap of such big subspace. In this case, we would like to change some parameters of our feature extraction stage network. Like we reduce the dimension of our original feature vector from 256 to 128 something to reduce the whole field to reduce the whole field space so that we could narrow the distribution of our instance vector, feature vector. And in this case, because training the whole network takes some time, we are still handling it. And also in our further plan, we would like to implement the social context network as well, so that it could leverage the relational information between the instance properly. And this is the these are all the about this semester's FYP project I proposed. And if there is any question, please feel free to leave a comment. Thanks for listening.